So today for exponential notation, we're going to go back. I'd say maybe first grade, okay? In first grade, you learned this, maybe kindergarten, you learned how to add, right? It was the best thing on the planet. You had the little, tigers, the little chips, and you counted them, and you were like, yes, I can add, right? And then one day, probably in second grade, they started to give you problems that looked like this. And you realize, man, this is getting to be a pain to add all these long numbers. So what did your teacher teach you? Multiplication, a shortcut on how to add long numbers. And so you realized then that you could group it. 1, 2, 3, 4, 5, 6 threes. And I knew that it was 18, and it was a shortcut to learn it. So then you really got into this multiplication thing, right? And so you learned all these multiplication facts like this. Woo! I know, 3 times 3 is 9. But soon enough, your 5th or 6th grade teacher started to give you problems that look like this. And of course, I am using X because back then you didn't know about the dot or the parentheses. And you're like, are you kidding me? 3 times 3 is 9. 9 times 3 is 27. 27 times 3. I don't know that in my head. What is this woman trying to do? So what did she teach you then? Exponents, or a way to group it so that you had an easier way to write something that looked this long. So what did you write? Tell me what it looks like. 3 to the power of the 6. So you learn this term power. Power represents our exponent. And what efficiently does the exponent mean? Tell me in words. How many times you multiply the big number by itself. But now we need to have a 9th grade term for that big number. Because you know that you write this as a big number with a little tiny exponent. So what is that big number called? The base. The base is your big number, with this being your exponent. And you can also know it as referred to power. And why is that? That is because when we have powers that look like this, you can't say squared or cubed. So in other words, you say 3 to the power of 1,000th or 1,000th. So you could say also 3 to the 1,000th power. Okay? So we use the words power to help us understand how we can represent that exponent. So power might be a new word to describe it for you, but it's a way to say it when it's not cubed or squared. Then you got, sometimes your teacher would try to trick you, and she would throw out problems like this. And your first reaction would be to go ahead and put it in exponents, right? But something was different. What was different? You have 2 different bases. And I love the way he used that new term because that's what we have to call it now. So what did you do in 6th grade to write something like this when it had different bases? You separated it. So what did this become? 3 to the 4th power, and this became 5 to the 2nd power. What did I put here? Okay, so let's talk about that. I heard 2 different things. I heard plus, and then I heard multiplication. Are they different? What operation is happening here? You're multiplying the whole thing through. So is there any addition? No. This is going to give you a way different answer than this. So we have to be careful as we're looking at representations, because this is saying add them together. This is saying continue the multiplication that was in the original problem. So from what we just learned, we already know a lot about exponents, right? So what I'm going to do now is all right, you already got your Eureka page. I want you to go to your first example. Go into your Eureka page. We're in lesson 1, and look what the title is, Exponential Notation. So at the top of the page, you have a rule box, and this is the following week when we're learning exponent rules, the rule box is going to be really important because each piece of exponents has a specific rule we have to follow. Today, we're just making sure we follow the rules of writing them. That's what that notation word means. So look at the first box. It says 5 to the 6 means, and they expand it. So you might want to write that this is expanded notation right here. So if they ever ask you to expand it, that's what they mean. I always think of it like a stretch. And look at the second example. It's a fraction. What did they do with the fraction? They put the parentheses because they have to be careful with where the exponent is going. Think about this for a second. This is what they wrote. What if I wrote it like this? Then the 9 would be the only thing that got the exponent. So it is very important when you are powering a fraction, you put it in parentheses. The parentheses is saying, hey, everything that's in here has to go to the power of 4. So what does that look like when I expand it? It would be 9 to the 4th over 7 to the 4th. Or it could be 9 over 7 times 9 over 7 times 9 over 7 times 9 over 7. These are both acceptable with fractions. Does everybody understand that? Now, you've seen this before because you've given me some background knowledge of exponents. So in algebra, they use variables to show us the rule. So the number x, do we know what x is? No. Does it matter? No, any number that's a base can be raised to a power n. Does it matter what n is? No, it can be any number. It could be 1,000. It could be 1,000,000. That's why we have graphing calculators. The numbers get huge. Can be raised to the nth power and be written as an exponent. So let's go to our first models. Look at the first set. So look at exercise 1. So for exercise 1, it is showing that 4 times dot 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 times 4. That's just a way to expand it instead of writing all the 4s. And then they show a brace 7 times. So if we want to write that in exponential notation, it would be 4 to the 7th power. Notice how I said it. Now look at the second model. It's a fraction, so what do I need to make sure I do? Put parentheses to keep it all together, and they want me to do it to the 21st power. Okay, so now I'm going to ask you, do exercise 2 through 10. You should only need about 3 minutes. Most people are wrapping up. Okay, so look at exercise 2. It showed us the actual exponential notation. So it wants to know how many times was the power. And the answer? 47. So you basically had to pull the exponent out of that problem. Now I kind of set you loose on this because I wanted to see what you would do. But look at exercise 7. What does exercise 7 show us that's different? A negative. Now we need to talk about that, because if I write a power with a negative like this versus a power with a negative like this, is there a difference? Yes, because the 2 is to the 13, not the negative. Here, the negative 13 is raised to the 2 power. So when you're dealing with negatives, you must use parentheses. Not to mention, if you expand it like this without parentheses, it would look like this, guys. Does that look normal with the negatives? The negative and the multiplication are like next to each other. That doesn't look right. So you need to make sure that you go in and you have parentheses holding that together. Do you have to put dots when you use parentheses? No, because parentheses next to each other actually mean multiplication. So for this one, it would be negative 13 in parentheses to the 6th power. Practice saying it. Again, for exercise 3, I have a negative amount. So the parentheses need to be there, and it is to the 34th power. Fraction and a negative. So what has to be there? Parentheses to the 10th power. Exercise 4, what is the exponent? 15. And exercise 9, x to the 185th power. See why that word power is important? It's a way for you to say it. What about exercise 5? Gotta keep the parentheses to the 10th. And then, of course, the last, how many times? And doesn't matter, that's just a way for us to express that however many times we need. Turn the page. Okay, so now I want you to take a minute with your partner. And I want you to look at exercise 11. It gives us 2 problems that we want to strategize. The first problem says, will these products be positive or negative? And how do you know? The first problem shows negative 1 to the 12th power, and the second one shows negative 1 to the 13th power. So I'm going to give you 1 minute with your partner to discuss it and determine what you think. Do you think this one will be positive and negative, or do you think this one will be positive or negative? 1 minute, begin. I should hear talking. And if you're unsure, talk to each other. Say what you think. It might joggle something. Must hear talking, and I'm not hearing it. This table's got good talking. That table, Raekwon's table's been talking. Make sure you're talking to Carmen. Let me tell you what I did here that I really liked. I heard Raekwon talking it out. He was really, okay, well, if this happens and it's going to be negative, and if I multiply this times this, he didn't know off the bat if his answer was right, but he was throwing out what he was suggesting could happen, or what might be the answer, or why he thinks that. I heard a couple important words coming out. This tells me that he's on the right track. But if you're not discussing it with your partner, you're losing out. You're missing out. Okay? So you need to start that habit, and we need to get better at it. So Raekwon, I'm going to let you take charge right now at this point in the class. Talk to me about your thoughts on this first one, -1 to the 12th power.
I say it would be positive because if it's an even number of negatives.
He is saying that he thinks it's positive because there is an even number of negatives with 12, so he thinks it's going to be positive. Can someone mathematically verify to me why that would be correct? How does he know that? What math is he thinking about that's making him realize that? Where did you learn a negative and a negative become positive?
7th grade.
7th grade, and what did you learn? Integer rules. So see, we're jumping back to week 1 and coming back in now with exponents. Your integer rules tell you, so let me give you a smaller problem to demonstrate. If it was -5 times -5 times -5 times -5, these two would become positive. A positive and a negative would be negative, and then a negative and a negative become positive. So he's correct, because this is 4. So when it is an even number exponent, then your answer is positive. So if that's the case, and Raekwon is correct, if -1 is to the 13th power, it's odd. Therefore, your answer should be negative.